We're looking at the differentiation of trig function, differentiations of trigonometric functions, and then we'll be looking at derivative. What is derivative of sine, cos, tangent, cot, cosec, which some people, which is a shortened form, this CSCX. Okay. This is what we'll be looking at. I think it's maybe one more. So if we've already established sin x, the differential coefficient is what? The y prime is cos x. This one has been explained, and we have proved it also in one of our videos using limits. 2. The differential coefficient of cos y prime is minus sine x. Okay. Then we want to look into tangents. Tan x. Tan x is sine over cos. Okay. And we are going to use quotient rule to solve this, because this is a numerator, this is the denominator. It's a fraction. So from quotient rule, y prime will be equal to, don't forget, it will be b squared. Okay, square this one, b squared, and that will give us cos square x. V, okay, times derivative of the numerator, which is also cos. Derivative of sine is cos, then minus numerator times derivative of the denominator, which is minus sine x. Okay. Then if you expand this, you're going to have, if you multiply this will be cos square x minus times minus, that's plus sine square x over cos square x. And then 1 plus cos square x plus sine square x is 1 over cos square x, which is written as 1 over cos x all square. And that will give us what? That will give us sec. 1 over cos is sec, and that will give us sec square x. Sec square x. So derivative of tangent is sec square x. So that's the third one. Then the fourth one, 4 cot, y cot 2. Want to see the derivative of these three functions. Cot is inverse of tangent, so that will be cosine over sine. Okay. Apply quotient rule also, because this is also a fraction. Apply quotient rule, and that will be equal to y prime equal to b square sine square x, then b sine x. Derivative of this is what? Minus sine x. Then minus the numerator, that's cos x, times the derivative of the denominator, that's also cos x. I'm using v equal to v du dx minus u dv dx all over v squared. That's the formula I'm using. Okay, my v is this one, my u is x. Okay, so that will be equal to minus sine square x, and then minus cos square x all over sine square x. Then we can take negative out from the numerator, factorize your negative, then you have sine square what? Sine square x plus cos square x all over sine square x. And that's minus 1. That's minus 1 over sine square x. Okay? and that will be equal to minus into bracket 1 over sine x, and that's what. So which is equal to 1 over sine x is cosec, 1 over sine is cosec, that will be cosec square x minus, and I don't want to use cosec square x, it's the same thing as saying minus c square x. Okay, the same thing. Okay, so the derivative of cot is minus cosec square x. Okay, then I skip something here. Sec. Let's quickly do the derivative of sec x. Derivative of sec x. There are 6 of them. If y equal to 5, if y equal to sec x, and sec is 1 over cos. 1 over cos. And I've said in the previous video on the quotient rule, this is the quotient rule. Okay, we'll be using quotient rule. We use quotient rule for tangents to get the differentiation. We use quotient rule also for this one also. Okay, so when the numerator is 1, it's very fast. It just be equal to minus dv dx over v squared. So this is my v. The derivative of this one is what? So I'm going to have y prime equal to minus the v dx is what? If I differentiate this one, that's what? Minus sine x all over cos square x, the v squared, that's cos square x. And that'll be equal to what? That'll be equal to sine. Minus times minus, that's sine over cos square x. Okay? So, and this will be equal to, you can split this one, this is equal to 1 over cos times 1 over sine x over cos x. Just split this one, this cos into 2 parts. Okay, with 1 on top and then sine over cos. Okay, then finally 1 over cos is what? Is sec. Is sec x, and then sine over cos. Sine over cos is what? Is tan. Is tan x. So derivative of sec is sec x tan x. Okay. Then the last one, cosec. The sixth one, y equal to cosec x, which you call the CSC, which is equal to 1 over sine. Okay. The inverse of sine is called cosec. So use the quotient rule also. We have this v squared v here. I'm even wasting time. Because my u is 1. So I don't need to do all these paparazzi, all this stuff. So that's minus the v dx over v squared. Minus the v dx over v squared. So this will be minus the derivative of cos is of sine is cos x all over the v squared sine square x. Okay. So we can also break this one. That will be minus. I can separate the minus 1 over sine x times cos x over sine x. And that will be equal to 1 over sine. 1 over sine is cosec minus cosec x, and then cos x. So that's that on the trig functions, differentiations of trig functions. We've done this. The derivative of sine is cos x. The derivative of cos is minus sine x. The derivative of tangent is what? Sec square x. The derivative of cot is minus cosec square x minus CSC square x. And the derivative of sec is sec x tan x. And the derivative of cosec is minus cosec x cot x. Okay, so that's that on this, and you have to try to. Okay, I think some exam will give you the table, and some will not give you. They'll give the formula sheet. Okay, Second and higher derivative. Yeah, we said that if y, if you have y is equal to f of x, okay, your first derivative y prime, which is also the same thing as what? F prime. This is called first what? First differential of first derivative. Okay, first derivative. Okay. The second one is just this also is also the same thing as what? This also is also the same thing as dy dx. Okay. They are the same. They are all the same. Then the second differential is you are differentiating again your first differential. You're differentiating again your first differential. ddx of your first differential, and that will give you the square y dx square, which is the same as y prime prime. So, or you can use f prime prime of the function. So this is called second derivative. Second derivative of second differential coefficient. Then the third one, you have ddx. You are differentiating your second differential. You are differentiating your second differential, which is equal to what? This ds cube. This is called third derivative. Third derivative or third differential coefficient. Then we can do one more. We can do one more. The other one will be equal to, you are differentiating your third differential, okay, yes, cube. That will be equal to what? This. So this is what? This is a fourth derivative of fourth differential. So, and the list goes on like that. It goes on and on like that. Okay, so that's that on that. Let's take one question here. Let's take one question here. It's minus y, and the fourth differential is y. So we are given this. Let's first of all do the first differential. The first differential will be equal to what? Cos x. Okay. Do it again. The second differential will be equal to, if you differentiate this one, that's minus sine x. Okay, that's minus sine x. And don't forget that sine x is what? It's y. So minus y. So this is what? This is done. We've done that. Let's continue. Can you do the third differential? So that will be ddx of the second differential. This is the second differential. Okay. Which will be equal to what? This is d3 dx4 dx3. Okay, equal to. If you differentiate sine x, you're going to have minus sine x is what? Cos x. Okay. Do it again. ddx of the third differential, which is the what we are looking for, fourth differential, equal to. Differentiate your cos. If you differentiate your cos, you have a minus. Differential of cosine is minus sine x, and that's equal to what? Minus, that's plus. That's what? That's sine x. And sine x is what? It's equal to y. So it's also